Section 1-3, equivalent expressions. So we're getting into, we've already talked about expressions, but now we're getting into equivalent expressions. So it says two expressions are equivalent, and I'm just going to write an equal sign because I didn't leave myself enough room there. If they have the same value for every value of the variable. So for example, a over 2 is equal to 1/2 a, because no matter what the value of the variable a is that we choose, we get the same value for both expressions. In this problem, dividing by 2 is the same as multiplying by 1/2. So one way we can confirm that, it says if a is equal to 10, for instance, we know that 10 over 2 is equal to 5. And for this one, 1/2 a, we would do 1/2 times 10, which is also equal to 5. So no matter the value of a that we choose, we get the same value when we evaluate it or simplify it. Example 1 says use the rules of arithmetic to explain why a over 2 is equivalent to 1/2 a. So what we're going to do here is we know the rules of arithmetic. If we multiply both sides of the equation by 2, on this side, 2 times a over 2 is just going to equal a. And then on this side, 1/2 times 2 equals 1. So that side also equals a. So there are many common errors in algebra, we know that, and they result from thinking that expressions are equivalent when in fact they're not equivalent. What's an easy way to determine if two expressions are equivalent? Think about that for a second, and we'll talk about it down here. So if you find a value of the variable that makes the expressions have different values, then they're not equivalent. So for instance, one that we're going to see on the next page is that x plus y, that quantity squared, equals x squared plus y squared. Okay, this is a very common misconception from algebra that those quantities are equivalent. One way to show that these two values are not equivalent is to pick values for x and y and substitute them in to prove that these two expressions right here and right here are not equivalent. So let's say we're going to make x equal to, let's say 5 and y equal to 3. So when we come down here, we're going to replace x with 5 and y with 3. So we want to do the quantity 5 plus 3 squared. That would give me 8 squared, which is 64. All right, and over here, we're going to replace x with 5 again, but we're squaring them before we add them, so y with 3. That's going to give me 25 plus 9, which is 34, and we can obviously see that they're not equivalent. So that's the easiest way, is to just choose values of x and y, or any variable, to show that these two statements are not equal. For example, 3a and 3b, you can pause it here in a second, and I want you to go ahead and do these on your own. And for both of them, let's use that x is equal to 5 and y is equal to 3. That way we're all consistent. So go ahead and pause it now and do what we did on the previous slide to confirm that these are not equivalent. Okay, now that you've checked yours, your work should look like this. 2 over 5 plus 3 is going to be 2 over 8, which we know is 1/4. And we're trying to determine if that's equivalent to 1 over 5 plus 1 over 3. We have to get a common denominator there of 15. So when we add those, this becomes 3/15, this becomes 5/15. So 1/4 being equal to 8/15 isn't close, because this one we know is less than a half, that's bigger than a half, so they're not equivalent. Okay, so we're going to do the same thing here for example 3b, and hopefully you've done both of these already. If not, you can just sort of follow along as we go. So once again, we'll make x equal to 5, y equal to 3. And here, this is a common misconception that you can just take the 2 and put it over one part of the fraction. So what we would have is 2 over 5 plus 3, which again is 2 over 8, which again is 1/4. And if we break it up like that, that would give you 2 over 5 plus 3, which is 3 2/5. We can just jump all the way down here, We can see that these are clearly not equal because that's less than 1, that's greater than 1, so there's no way that they're equal. So the next thing it mentions here is that there's this warning: checking values cannot show you that two expressions are equivalent because they could have multiple solutions. So if you see the expressions 2x squared minus 5x plus 3, so if we write that one out, 2x squared minus 5x plus 3, and then the other expression, x squared minus 2x plus 1, both have the same value when x equals 1 and when x equals 2. All right? Are the expressions equivalent then? And hopefully you can look at those and see that they're not. They're not going to be equivalent. But the way we confirm that they're not equivalent is to pick one other value to show that they're not equivalent. So let's say if you picked x is equal to 3 and tried that and plugged it in. So we get 2 times 3 squared minus 5 times 3 plus 3. So that's going to give me 18 minus 15 plus 3, which gives me 6. And over here, I'm going to do 3 squared minus 2 times 3 plus 1, which is 9 minus 6 plus 1, which is 4. So since these two expressions back up here at the top have different values when x is 3, they're not equivalent, even though they're equivalent at those 2 points. So here's a word problem that puts this comparing expressions into a real-world situation. It says to convert from miles to kilometers, Abby doubles the number of miles, so she's going to double the number of miles, then decreases that result by 20%. Renato, we'll write his in green, first divides the number of miles by 5 and then multiplies the result by 8. So they want us to write an algebraic expression for each method. So for Abby, and we'll write Abby here, it says that she doubles the number of miles, so that's going to be 2m, then she decreases that result by 20%. All right, so take a second to think about how we would write that. So she's going to do 20% of 2m, and she'll decrease that from the original 2m right there. Okay? Renato, he first divides the number of miles by 5, and then multiplies that result by 8. And down here for part B, it says use your answer to part A to decide if the two methods give the same answer. And what we're going to do is we're going to simplify. So we're going to take this right here, and that's going to give me 2m minus 0.4m, which is 1.6m. And for Renato, when we multiply this, it's m over 5. And remember, you can rewrite 8 as 8 over 1. So it's going to be 8m over 5, and if you do 8 divided by 5, you also get 1.6m. Since these two are exactly the same, they will always give us the same answer no matter what value you plug in for m. So they both converted it slightly differently, but ultimately both methods work. Therefore, both of these expressions up here are equivalent. So the last thing mentioned here in section 1-3 is when you say that you have two expressions that are equivalent, such as x plus x and 2x, what you're really saying is that for all numbers x, so any number you can plug in for the variable, we have x plus x equals 2x. So now this obviously looks like an equation because there's an equal sign. So in order to distinguish this use of equations from other equations that we're going to solve, we refer to a problem like this where x plus x equals 2x or anything set up similar to that. We refer to that as an identity. Okay, and if you think back to Algebra 1, if you were to try to solve that, you'd get that x could equal all real numbers, so that's an identity. This is a really special equation, one that is specifically satisfied by all values of the variable, so all real numbers, if you remember that from Algebra 1.